Hello everyone. Our topic today is linear momentum and Newton's first law of motion. The study of moving bodies began by Galileo Galilei in Italy and was continued after his death by Sir Isaac Newton in England. Newton was devoted mainly to the study of motion, particularly that of the planet and other heavenly bodies. Newton sums up the basic principle of motion in three laws, that is Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. We'll be concentrating on Newton's first law of motion. Newton's first law of motion states that every body continues in its state of rest or of uniform motion in a straight line, unless compelled by some external forces to act otherwise. We know that a body at rest will be at rest, but a body in motion will not continue in motion in a straight line as he has explained. A body in motion will definitely come to rest after a while. It is common experience that a body at rest will definitely remain at rest. But a body in motion will only continue in motion in a straight line when all the various outside forces like air resistance and gravity, which can retard a moving body, are all eliminated. When a bullet is fired from a gun, sooner or later the bullet returns to the ground. A footballer that kicks a ball, the ball moves in a straight line. After a while, it will stop. This is as a result of air resistance and gravity, which retards moving bodies. A person riding a bicycle along a level road does not come to rest immediately he stops pedaling. The bicycle continues to move forward and later stops as a result of air resistance and friction. In space, there is no gravity and no air resistance. Newton explained that planets move in curved paths because the sun is attracting them to itself. They are to continue moving since there was no retarding force. If the attraction of the sun suddenly ceased, a planet will continue to move in a straight line. In a moving vehicle, when brakes are applied, the vehicle stops, but not the passengers, who can be injured when they hit the windscreen. So there is need for a safety belt. The tendency of bodies to remain in their state of rest or of uniform linear motion in the absence of applied force is known as inertia. This is the reluctancy of a body to move while at rest or a body in motion to suddenly stop. Some simple party tricks are based on this principle. For example, you need two bottles of the same kind, one filled with a colored liquid visible to the audience and the other empty. The empty bottle is placed upside down over the filled bottle with a naira note in between the two mouths of the bottles as shown. The two bottles are turned upside down with the filled bottle on top of the empty bottle. The naira note is held at the edge and quickly pulled out with the two bottles still in place, and the liquid from the bottle on top runs down into the empty bottle. Newton introduced the concept of momentum as the quantity of motion. Momentum is the product of the mass of a body and its velocity, and is given by the formula rho is equal to rho, which is the momentum, is equal to mass times velocity. Now let's take an example. A truck of mass 5.0 times 10 raised to power 3 kilogram moves with a velocity of 3 meters per second. Calculate the momentum. We start by using our formula rho is equal to mass times velocity. We substitute in our values 5.0 times 10 raised to power 3 times 3. That will give us 1.5 times 10 raised to power 4 kilogram meter per second. When two bodies collide, let's assume two boys ran into each other. Each of these boys will feel the impact of the collision. They will feel this impact as a pain. The time of collision is very short. Impulse is the product of the average force F acting on a body and the time t during which it acts. That will give us I, impulse, is equal to force times time. Let's take an example. When taking a penalty kick, a footballer applies a force of 30.0 Newton for a period of 0.05 seconds. What is the impulse experienced by the ball? You will use our formula impulse is equal to force times time. Substituting in our values, we have 30 times 0.05 and our final answer will be 1.5 Newton seconds. If you like the video, give it a like and don't forget to subscribe. If you have any question, drop them at the comment section below and I will respond to them as soon as possible. Bye.